Hi guys and welcome, it's Mr. Mustafa here. In today's video we are going to be solving the Mathematics Paper 1 June 2021 supplementary examination. So if you want to have a look at the paper, we've got question 1 here. Right, so let us start with question 1. I've cut them out in parts so don't have to go back and forth just to save time. Right, so question 1.1.1, we've got x squared minus x minus 20 is equal to 0. If we identify this equation here, it's a quadratic equation, right? And just a quick hint, if they don't say correct to 2 decimal places, it will probably factorize. So let us factorize this. We have 1.1.1, we got x squared minus x minus 20 is equal to 0. If we solve this equation, can factorize x minus 5 into x plus 4 is equal to 0. So you've got x is equal to 5 or x is equal to minus 4. It's good to check whether if you factorize correctly. You can see minus 5 plus 4 is minus x, and then we got minus 5 times 4, which is minus 20. If you want to use a calculator and work backwards, of course you can do that. Let me just show you. If you got this silver calculator, it can actually do the trick. You press mode, you go to equation which is 5, and if you go to number 3, which is a quadratic equation, right, 3, and you enter the coefficients of x squared minus x and minus 20, you can enter 1 equals, minus 1 equals, and minus 20 equals, and we get the answer x is equal to 5 or x is equal to minus 4. So if you have x is equal to 5, x is equal to minus 4, you can work backwards and bring it over. So x plus 4, bring it over x minus 5, right? Let's look at question 1.1.2. Since they say correct to 2 decimal places, it's still a quadratic equation, we need to go and use the quadratic formula, which is in your formula sheet. So what's the equation? 3x squared minus 2x minus 6 is equal to 0, right? So your value of a is 3, b is equal to minus 2, and the value of c is equal to minus 6, right? Now the quadratic formula is x is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. Minus b will give us, you can just enter it directly as it is, plus minus the square root of b squared minus 4ac, which is minus 2 squared minus 4 times 3, which is a, and times c, which is minus 6, divided by, just put a line here, divided by 2 times a, which is 3. Now if we enter all this on our calculator, right, remember to work out the inside. Obviously we can simplify the first part, minus and minus makes 2, plus minus the square root of, enter it on the calculator. We want the value of this. You can see 2 squared is 4, put it back mode, computation mode. So we got 4 minus 4 into 3 into minus 6, press equals, we're finding the square root of 76 divided by 6. What's the square root of 76? You can just say square root answer, and your answer is 2 root 19. So let us just write this down. So 2 plus minus 2 root 19 divided by 6. If you had to go and simplify all of this, sometimes they tell you to write the answer in third form. So if you have to go and write the answer in third form, how will you simplify it in a simple third form? Remember guys, you can just type all this out on the calculator and just get your 2 answers, right, which will be more correct. But let's see, you can go straight from here to the final answers. So the third form of this answer, you can factorize the 2 on top, and you can divide by 2 at the bottom. So if you divide the top by 2 and divide by the denominator by 2, you should get 1 plus minus the square root of 19 divided by 3. So the third form answers are x is equal to 1 plus root 19 divided by 3, or x is equal to 1 minus root 19 divided by 3. But we want the answers in to correct to 2 decimal places, so I can just type this in the calculator. So what I have is, for the fraction, 1 plus the square root of 19 divided by 2. I've got an answer of divided by 3, got an answer of, press the SD button, 1,79786. look at the third decimal place, which is more than 5, more than equal to 5, so round off to the next one, 1,79, or x is equal to 1 minus square root of 19 over 3, and press the SD button, you get negative 1,12. That's the third decimal, so it goes to negative 1,12. Let's see if we get the same answer if we type all this out. Remember, you can just go direct from here to the final step. You should get all your answers. This was just to show you that these are the third answers. Right, so we can get this answer here as well. Right, so x is equal to, just by typing all of this in the calculator as it is. So mode, just for, alright, so you say minus 2, come on guys, that's simple, that's just 2, plus the square root of this minus 2 squared, you should just get 4, minus 4, a is 3, right, and c is minus 6, close the bracket, divided by 2 times 3, which is just 6, right? So we got 1 plus root 19 over 3, as I simplified it into third form, and I've entered that. You should get 1,79. Just check it. You get 1,79, and then the top, change that into a minus, and we're getting 1 minus root 19 over 3, and press the SD button, we get minus 1,12. So which is 1,79, or x is equal to negative 1,12. Right, exact same answers. Or if you use this function, the built-in function, if you have a calculator like this, and if you use a built-in function, if you go to equation which is 5 and look at number 3, right, and enter these values, what were the a value? A value was 3, b value was minus 2, and the c value, see here, a value is 3, b value is minus 2, and c value is minus 6. That's what we had. And you can see we're getting 1 plus root 19 over 3. You can put down the answer, but make sure this is the most important step. You must have this quadratic formulas, the substitution into the quadratic formula down, and then you can write down these two answers. You should get 2 marks here, one there. Right, hope you understand, guys. 1.1.3, we have x minus 1 all squared is greater than that, so we have a quadratic inequality here. Right, so in order to solve this question, we can just square the left hand side, bring the 9 over, refactorize, and solve using number line or graphs. You can use, there's multiple ways to solve this, right? So you can also use graphs, or let's just use the number line method, which is much more easier. X minus 1 all squared is greater than 9, 1.1.3. So yes, 1.1.3, x minus 1 all squared is greater than 9. Let's just check the question again. Yeah. So as we discussed, we're going to open the left hand side. If you open the left hand side, is squaring a binomial, so we got x squared, the product of these two times 2, which is minus 2x, and square the minus 1, you get plus 1, bring the 9 over, minus 9, which is greater than 0. If you simplify this equation, we get x squared minus 2x minus 8, which is greater than 0. This here should factorize x and x, which is greater than 0. I haven't seen any quadratic inequality that doesn't factorize in like question 1, guys, right? So most of the time it does factorize, like 99% of the time. So let's see, x squared minus 2x minus 8 is greater than 0, so 4 and 2 should work. So if you say minus 4 and plus 2, minus 4 plus 2 is minus 2, and 2 times minus 4, we should get minus 8. So just check the sum for this and the product for this, right? Now we draw a number line. If I draw a number line and take the critical values, what are the critical values? Critical values are values that will make the first factor equal to 0, so which is minus 2, and the critical value for this is 4. Now remember, this number line is divided into 3 parts, part 1, part 2 and part 3, because of these critical values. Now if I choose any value after 4, just choose a value after 4 and substitute inside here, right? If I choose a value after 4, you should just choose a value 10, and if I substitute here, do I get a positive or a negative number? So positive here, 10 plus 2 is positive, and 10 minus 4 is, we get a positive. And then between minus 2 and 4, if 0 lies between minus 2 and 4, so if I substitute 0 here and 0 there, you should get negative and positive. So if your quadratic equation usually factorizes like this, and you have linear factors here, you can always alternate the sign. You can just go plus minus plus, right? Provided the coefficient of x squared is positive and these are linear, so you can always go plus minus plus. And the solution that we are looking for is a solution going in this direction. Remember, we can't include 4 because it's not an including sign here, and we can't really include the plus 2. Right, so not including, and we're looking for a solution going in that direction. So this answer basically means x is less than minus 2 or x is greater than 4, because these are the solutions that will make this equation true. You can clearly check if you substitute any value between minus 4 and minus 2 and 4, this inequality won't hold. Example, if you substitute the number 0, you're getting 1 which is greater than 9. Is 1 greater than 9? No, it is false. So the only answer, the solutions that will work is less than minus 2 or greater than 4. I hope you understand, guys. Leave a comment if you don't understand. Right, 1.1.4. Now in 1.1.4 we have a third equation, right? So third equation. So let us solve the third equation. So 1.1.4, we got 2 square root of x plus 6 plus 2 is equal to x, right? So I'm just going to copy this down. That's the equation we have. Make some space here, right? And right, that's the equation for 1.1.4. So in order to solve this third equation, we keep the third on the left hand side and take all the numbers over, right? So take all the non-thirds over. So we have 2 square root of x plus 6 is equal to x minus 2. Now in order to get rid of this, don't divide both sides by 2, then you will be dealing with a fraction here. In order to get rid of this third over here, we need to square both sides. But before we square both sides, remember the type of solutions that we are looking for. So 2 times the square root of a number, the square root of a number needs to always be positive. So therefore x minus 2 must be greater than equal to 0. That's just a restriction. Or you can just solve the solution and look for the solution that we are looking for. So this is a restriction. So x has to be, the answer for x must be greater than equal to 2. So that's the solution that we are looking for. Answers that are greater than equal to 2. So let us solve this by squaring both sides. So if I square this side, and if I square the left hand side and the right hand side, we should get, square the 2, we get 4. Square this, get x plus 6, square the third, if you square square root, falls off, which is equal to, if you square this binomial, getting x squared, product of these two times 2 minus 4x, and square the minus 2, you get plus 4. So let's not say 0 equal, let us open this side. We're getting 4x plus 24, 4 times 6 is equal to x squared minus 4x plus 4. So we can say 0 equals, bring everything over on this side because the x squared is positive here. X squared minus 4x should give us minus 8x. 4 minus 24 should give us minus 20. Now solving this equation, you got 0 equals yes, 0 equals x squared minus 8x minus 20. So factors of 20, 10 and 2, 4 and 5. So we can see 10 and 2, 10 times 2 is working. So we can use 10 and 2, in other words minus 10 and plus 2 to get minus 10, minus 10x plus 2x should give us minus 8, and check the product, minus 20. Therefore x is equal to 10 or x is equal to minus 2. So using this restriction, we can clearly see that minus 2 does not work, so we need to write reject. Otherwise, best thing, just check this answer by substituting into the original equation. If we substitute minus 2 in the original equation, remember minus 2 plus 6. Minus 2 plus 6 is 4. The square root of 4 is 2, right? And 2 times 2 is 4. 4 plus 2 is 6. Is 6 equal to minus 2? No. So we wrote reject, which is basically correct. If we substitute the other equation, which is x is equal to 10 inside here, let's check. 10 plus 6 is 16. Square root of 16 is 4. 4 times 2 is 8. 8 plus 2 is 10, and 10 is equal to 10. So the only solution is x is equal to 10. We must write reject, otherwise you will lose a mark. Let us move on to the next question. Alright, so what do we have here? Alright, so we have solve for x and y simultaneously. Alright, so we want to solve for x and y simultaneously, which is we have a linear and a quadratic. So if you have a linear and a quadratic, make the easy on the subject of the formula, which is the linear one. Right, so 1.2, what we will say is, right, so we have 4x plus y is equal to 2, make y the subject of the formula. So we're going to say y is equal to 2 minus 4x. Don't make x the subject, because if you make x the subject of the formula, you will end up with a fraction. So make y the subject of the formula. And what we have, and we have 4x plus y squared is equal to 8. Now we have 4x plus y squared is equal to 8. Let's do this. What we can do here is, remember we solve for y, so we need to substitute in the place of y. So substitute this in the place of y. So we got 4x plus 2 minus 4x is equal to 8. 2 minus 4x all squared. Now we have 4x plus, opening this equation up, 2 squared is 4. 2 times minus 4x is minus 8x, times 2 is minus 16x, squaring a binomial, and squaring minus 4x, right, we're getting plus 16x squared is equal to 8. Now making a quadratic and solving everything, that's what we need to do. So we got 16x squared, we have minus 16x plus 4x, which is minus 12x, and then we have 4, we have the 4 and the 8, right? So we have the 4 and the 8, 4 minus 8, which is minus 4 is equal to 0. 16x squared minus 12x minus 4 is equal to 0. Remember to write this equation in standard form and then solve. Let's make some space here, right? So dividing everything by 4, so we should get 4x squared minus 3x minus 1 is equal to 0. We should be able to factorize. How can we factorize this? Can we use 4 and 1, or what should work? Let's see. Let's try 4x and x is equal to 0. So yeah, so 1 and 1. So that should be minus 4x minus 4x plus 1x should give you minus 3x, and 1 times minus 1 is minus 1. Therefore x is equal to negative quarter, or x is equal to 1. Now since x is equal to negative quarter, we can take this value of x and substitute into y. So what's y equal to? Y was 2 minus 4x, so 2 minus 4x. Now remember, x is minus quarter, so you're going to substitute 2 minus 4 times minus quarter, and we should get an answer of 4 times minus quarter. The 4 and the 4 cancel out, minus and minus. So if you enter all this in the calculator, you can just say 2 plus 1, which is equal to 3. So y value is equal to 3, or let's substitute y is equal to 2 minus 4 times 1, and 2 minus 4 times 1, 2 minus 4, which is equal to minus 2. So what are the solutions? Solutions are, if you're writing it in coordinate form, you're going to write minus quarter, x is equal to, okay, leave out the coordinate form, let's just write it like this, x is equal to minus quarter, and y is equal to 3, and the other solution is, or x is equal to 1 and y is equal to minus 2. So please check if these things actually work inside here, right? So yeah, always go back and check if these solutions work. Let us just check this second solution, 1 and minus 2. If I substitute 1 and minus 2 inside here, does it work? Let's check. So if I substitute 1 here in the place of x, that's 4, and minus 2. So 4 minus 2 is 2. Works perfectly, right? So your solutions are correct. Now the second question, if it is given that 2x times 3 to the power y is equal to 24, determine the numerical value of x minus y. So basically this is from prime factorization, where you have to decompose the right hand side, 24 to the power 6, in terms of base 2 and base 3. So let us do that. So we have 2 to the power x. I'm just going to write the question and copy it down. So we got 2 to the power x times 3 to the power y is equal to 24 to the power 6. We want to find the numerical value of x minus y, right? So let me just copy this down and you can solve it. It's not difficult, guys. This section is coming from prime factorization. You even have like that function on the calculator, especially the silver calculator, which is fx991 za plus. Alright, got copied this side. Right, shouldn't be copying, I should have cut it out. Let's delete this portion out from here. I think we had one more, we have actually copied it, so let's delete it. Yeah, let's delete this out as well. Alright, so far so good. Let's look at the number 24. Alright, so to decompose 24, let's write it here. Alright, so if you want to decompose 24, the number 2 can go inside, then you got 12, 2 can go inside it, the 12 again, so 6, 2 can go into this, so we have 3 can go in there, and we have 1, we stop. So 24 is basically equal to 2 cubed times 3. Therefore 24 is equal to 2 cubed times 3, 8 times 3. So that's what we're going to enter here, which is 2 cubed times 3 to the power 6. And now what do we have? We got 3 times, we're raising a power to a power, so we multiply them out. Right, so what we need to do is we need to multiply here and multiply them out here. So 3 times 6, 2 to the power 18, and 1, this is 3 to the power 1, so 1 times 6, which is 3 to the power 6. So if you're comparing apples for apples, that's 2 to the power x equals 3 to the power y. You can see 2 to the power x here, 2 to the power x here, You can see 3 to the power y here and 3 to the power 6 there. So clearly x is equal to 18, y is equal to 6. So remember, x is equal to 18 and y is equal to 6. Therefore, x minus y is equal to 18 minus 6, which is equal to 12. Easy peasy. Right, let us move on to question number 2. Right, so question 2, what we have in question 2 is consider the quadratic sequence. Now since they have told you that it's a quadratic sequence, you can straight away go and draw the tree and solve for the stuff. So question 2.1.1, we have Tn, determine Tn, the n term of the quadratic sequence. So let us draw the tree. So 2.1.1, we've got 72, 100, 120 and 132. So these are your the terms. These are your difference ones, right? And then we need difference 2 at the end. So remember, for a quadratic sequence we need to check if the second you don't need to check actually to if you want to prove that it's a quadratic sequence, the second differences needs to be constant. But in this case it's already a quadratic sequence, so you can go straight ahead and use the formula to calculate Tn, right? So 100 minus 72, we have 28 here. 120 minus 100, that is 20, and 132 minus 120, which is 12. Seems like we are subtracting minus 8 each time here. So 20 minus 28, 20 minus 28 is minus 8, and you can clearly see 12 minus 20 is minus 8. So these are your formula. Let's just write down the formula. Right, so 2a is equal to d2, and that's how you solve for what's your d2. Your d2 is here, your d1 is here, and your term 1 is here, right? So 2a equals d2, 3a plus b is equal to d1, and a plus b plus c is equal to term 1. A plus b plus c is equal to term 1. Right, so 2a is equal to minus 8, which is d2 value, the second differences. So a is equal to minus 4, minus 8 divided by 2. So 3 times minus 4 is minus 12, plus b is equal to difference 1. Difference 1 is 28, the first value of difference 1. Right, so b is equal to 28 plus 12, which is 40. And then what we have here is a is minus 4, b is plus 40, plus c, which is equal to term 1. What is term 1? 72. Right, and then what we have here on this side is minus we have 36, minus 4 plus 40, which is 36, and 72 minus 36, we should get c is equal to 36. Let's do that quickly on the calculator. What are we doing? We are saying, alright, so mode, put it back into the normal computation mode. So we got 72, take the minus 4 over, you say plus 4, take the 40 over, minus 40, which is equal to 36. Right, so your Tn is an squared plus bn plus c. Therefore, your Tn is equal to an squared plus bn plus c. So what is your ABC? Right, so you can write ABC is a is minus 4 n squared plus 40n plus 36, and that it's nice to check. Substitute the value of n, which is 1, and see let's substitute the value of n, which is 2, and see if we get 100. Right, So just double check your answer. So what we have is minus 4 into 2 squared plus 40 into 2 plus 36. We are getting 100, so it looks like this answer is correct. Right, next one. A term in the quadratic sequence is 72, 100, 120, 132. A term in the quadratic sequence, so we don't know which term it is, so let us call it Tn. A term in the quadratic sequence, which is Tn, is equal to, so some term over here in the quadratic sequence, we don't know which term it is equal to the 12th term of the first differences. A term in the quadratic sequence is equal to the 12th term of the sequence of the first differences. Determine the position of this term in the quadratic sequence. So we want to know which term it is over here in the quadratic sequence. So they're telling us is equal to the 12th term. So we need a Tn formula for difference 1. Let's calculate the Tn formula for difference 1. So basically, if you have to set up an equation which is Tn is equal to difference formula, right? So let me just call it dn, all right? Because remember, this is Tn, this is dn, all right? So difference 1, in other words, difference 1 Tn, that's what you're looking for. So n in this case is going to be 12, right? So let us write this down. 2.1.2. So Tn is equal to, now to remember your difference 1 is linear, you're basically subtracting 8 each time, right? So since we're subtracting 8 each time, it is just minus 8n, right? So what I use is Tn is equal to bn plus c, right? So what are you doing each time in your linear sequence? You are basically subtracting 8 each time, right? Since we're subtracting 8 each time, just minus 8n. So this is my difference 1 formulas, right? So Tn is equal to bn plus c for difference 1. And what would the term be before this? So since we're subtracting 8 each time, you can just add 8 here. And if you add 8 here, it would have been 36. Or to find the same thing, you can also use your Tn formula, which is a plus n minus 1 d to get this answer. So if you do that, should get, just insert some space here, right? A plus n minus 1d, your first term is basically 28 in your difference 1, plus n minus 1 and minus 8 here. Right, so what we have here is minus 28 minus 8n plus 8. You can see you're getting minus 8n plus 8. So this is your Tn for your difference 1 formula. So this is difference 1 formula. Now they're telling us we need to find term 12 of the first difference. The term 12 of the first difference is equal to Tn, a particular term inside here, right? So let's look at this. Term 12 is minus 8 into 12 plus 8. If you put that in your calculator, which is minus 8 into 12 plus 8, should get minus 88, right? So therefore, we need to equate this. We need to equate the quadratic Tn. We need to equate the quadratic Tn, a term in the quadratic sequence, which is Tn, is equal to the 12th term of the sequence of the first differences. So the 12th term of the sequence of the first differences is equal to minus 88. So Tn is equal to minus 88. This is for the quadratic Tn, right? Let's take that Q out. So what was the quadratic Tn? We have solved before, which is minus 4n squared plus 40n plus 36. And let's bring this minus 88 over and set it equal to 0. Is that correct? Minus 4n squared plus 40n plus 36. Yes, there's it here. And set it equal to 0. Now let us write this in standard form and then divide everything by. So we got minus 4n squared plus 40n, 36 minus 88 quickly. Right, so we have 36 minus 88. I'm getting minus 52 is equal to 0. We're going to take minus 52 and divide it by minus 4, right, to put it in standard form. Dividing by minus 4 should get 13. So plus 13 here. Remember, we are dividing by minus 4. So n squared minus 10n plus 13 is equal to 0. N squared minus 10n plus 13 is equal to 0. This won't factorize. So what did we, I think we made a mistake here somewhere then. Oh, took this minus 88, bring it over, we should get plus. So just watch. So obviously if something does not work out, always check your equation. So that should be a plus, right, and that should be a plus. So plus 36 plus 88 should give me 36 plus 88 should give me 124, right? So should give me 124, and take 124, and if I divide it by 4, right, so take 124 and divide it by 4, should get 31, but remember minus 31 in this case. Oh, it was plus 124, so you should get minus 31 here. Correct, because we're dividing everything by minus 4. Hundred and 124 divided by 4 should get 31. Still have a problem here, guys. Let's check if this is done properly. It's minus 8n plus 36, that's the difference 1 formula. Term 12 of difference 1, is it minus 88? Yes, that is correct. Minus 8n, okay, made a mistake here. Minus 8n plus 8, that's where the error is. Minus 8n plus 8 shouldn't be plus 8, should be plus minus 8n plus 36. I had it here, right? Minus 8n plus 36 again, plus 36 here. Just quickly correct this. Plus 36. I need to change this as well. Minus 8 into 12 plus 36. You can see we are getting minus 60. Yeah, this should work out. Should get minus 60. Just erase this off. We're getting minus 60 here, right? And change this. Should be minus 60 as well. Right, so always go back to your original and see what you did wrong. Sorry about this. Minus 60. Bring it over. 60. Should get 96 here then, right? 36 plus 60, you should get 96, and then dividing everything by minus 4, 48, 24, you should get 24, because you can clearly see it's not factorizing, right? So should get minus 24. 96 divided by 4, see, 96 divided by 4 should get 24, correct? So minus 24. Now it looks like it's going to factorize, so n and n. So guys, always go back and check. Obviously if you make errors, right, it's a learning curve, so if you make errors here, go back and check if you can factorize it again and again. Right, so I think we can use 12 and 2, so minus 12 plus 2, you can see minus 12 plus 2 gives me minus 10, and 2 times minus 12 is minus 24. So n is equal to negative 2 or n is equal to 12. So it can only be, remember, we need to reject this. Why are we rejecting this? Because in a quadratic sequence, n represents the number of terms, so n has to be an element of natural numbers, right? So that's a symbol for natural numbers. N has to be an element of natural numbers. You can clearly see this is not an element of natural numbers. So we are going to, you can clearly see it's not an element of natural numbers. That's why we are rejecting. Not an element, you can just strike off the element sign. It means N is not an element of natural numbers, therefore reject this. So you can't get the value of N as negative, 0, and you can't get the values of N as fractions, right, or rationals. So N is equal to 12. Therefore, term 12, the 12th term. So what did they ask us? The 12th term of the quadratic, a term in the quadratic sequence. So they asked, determine the position of this term in the quadratic sequence. Term 12 in the quadratic sequence. It is term 12 in the quadratic sequence, right, is equal to the 12th term in difference 1. Now if you substitute 12 in your quadratic sequence, you should get an answer of minus 60. So let us just check, right? So I'm going to substitute minus 12 in my quadratic sequence here. So I've got minus, so let's just check up this answer, minus 4 into 12 squared plus 40 into 12 plus 36. Lovely, I'm getting an answer of minus 60. So minus 60 is part of the above quadratic sequence, which is the 12th term, right? Nice question. Right, determine the maximum value of the quadratic sequence. So 2.1.3, to determine the maximum value, you have many ways. You can find the derivative, or you can find the x value of the turning point, right, and substitute into the original function, or you can just use minus delta over 4a. So many ways. So there's three ways to find the maximum value. You can find the derivative, set it equal to 0 and substitute into the original function, or you can just use the formula minus delta over 4a. So let's see which is the easiest way. Obviously not going to remember everything, so let's just use the derivative. So use calculus. 2.1.3. so we got Tn, which is minus 4n squared. We want to find the maximum value of this quadratic sequence, plus 40n plus 36. So if you find Tn prime, derivative with respect to n, you're getting minus 8n plus 40, set it equal to 0. We're going to get minus 8n, which is equal to minus 40. Therefore n is equal to 5. So the fifth, so we want the maximum value. Okay, if you want the maximum value, you take the value of n and you substitute into the original inside here. So therefore T5 max is term 5, which is equal to, maximum value is term 5, which is equal to minus 4 into 5 squared plus 40 into 5 plus 36. You can use a calculator and solve this quickly, right? So minus 4, right? So minus 4 into 5 squared plus 40 into 5 plus 36, and we're getting 136. So is 136 part of the sequence? That's what we want to check. Yeah, so you got 72, 100, 120, 132, and if you look at this, remember it's 20, 12, you're minusing 8. If you minus 8 from here, you should get 4, and you're kind of like adding 4. 132 plus 4 will give you 136. So it is part of the sequence, right? So term 5, the maximum value is 136. Or guys, you can use the grade 11 formula, or max value of the sequence is negative delta over 4a. What is negative delta? Negative b squared minus 4ac. So b squared is 40 minus 4. What is a? Minus 4. And the value of c was 36. So we're taking the value b squared minus 4ac, right? That's what delta is. divided by 4 times minus 4. If you enter all this on the calculator, your maximum value of that quadratic sequence should end up being 136. Let's check. So we got minus on the outside, fraction, we got the minus on the outside, and you're saying 40 squared. You can see minus and minus, so I'm just going to say minus 4 times, alright, so let's just enter it as it is, minus 4 into minus 4 into 36, right, close bracket, divided by 4 times minus 4, right, you're getting an answer of 136. So see how simple this formula is. You don't need to find derivative, nothing, you just use the grade 11 formula, right, so which is minus delta over 4a to get the maximum value straight. You don't even need to solve the x value, right. Nice question there as well. Now determine the maximum value of the sequence. What is the sequence? So 2.1.4, we want to find the maximum value of the sequence. I'm just going to copy this question and then paste it down there. So 2.1.4, we've got the sequence minus 23, 5, 25 and 37, right. It's just for 1 mark, so I'm sure you don't need to do too much of calculations there, right. So there should be a trick. So 2.1.4 is that, right. If I look at the original sequence, since it's part of the same question, right, so 2.1.4, I'm sure you got to do something with the original question. So 72, 100, 120, 32. So the original sequence was 7200. It was 7200, 120 and 132, right. If we take the differences here, the differences here and the differences there and the differences there, I just want to check here if it's a quadratic sequence. So 5 minus 23 is minus 18, sorry, minus 28, no, 5 minus minus 23, erase this off, that is incorrect. So 5 minus minus 23 is 28, 25 minus 5 is 20, and 37 minus 25 is 12. Take the difference, we're getting minus 8, take the difference, we're getting minus 8. So I'm sure it got something to do with this sequence. So this was already 28, 20 and 12, and that was already minus 8, and that was already minus 8. Right, so solving this, we can see what was the formula for this. The formula for this is Tn is equal to minus 4n squared plus 40n plus 36. And what should be the formula for this? We can see this is 72 and this is minus 23. So this sequence is starting from minus 23 and this sequence is starting from 72. So the link between these two should be what was the max value? Max value was equal to 136. So this sequence, the original quadratic sequence, is actually shifted left by how many units? So that's 72 already, 72 plus 23. So 72 plus 23, 72 plus 23, if you add that up, right, so let's see. So 72 plus 23, we're getting shifted 95 degrees to the left, right. So this sequence here is 90, so not degrees, shift is 95 units to the left. I'm talking about trig here, sorry guys. So it is shifted 95 units to the left. So if you shift 95 units to the left, you should get 100 minus 95, which is 5, 120 minus 95, which is 25. Alright, so everything is working out. So it is definitely shifted 95 units to the left. Therefore, max value of this, max value is equal to 136 minus 95. If you say 136 minus 95, you should get 41 as the answer. Let's just double check on your calculator. If you check on your calculator, 136 minus 95, and we are getting 41. Perfect. Let us proceed to the next question. Right, so consider the sequence minus 11, 2 sine 3x, and 15. Determine the values of x. So we want the values of x, right, in the interval 0 to 90, for which the sequence will be arithmetic. Now we have a special property of the arithmetic sequence. Remember, term 2 minus term 1, the common differences are the same basically. So 2 sine x, so do we know about arithmetic sequence? So t2 minus t1 should be equal to t3 minus term 2. In other words, the common differences are the same, right? Common difference, right? So common difference, term 2 minus term 1, which is 2 sine 3x, minus 11 is equal to term 3 minus term 2, which is 15 minus 2 sine 3x. So simplifying everything, bringing all the signs over, the trig ratio on one side and numbers across. So you got 4 sine 3x, because you got minus 2 sine 3x goes over, becomes 4 sine 3x, and you got 15 here, and 15, this is plus 11 on this side, and minus 11 should give you 4, right? Therefore sine 3x is just equal to 1. Sine 3x is equal to 1. Make some space here. Now sine 3x is equal to 1. How do we solve this equation? A reference angle, right? Reference angle is equal to sine inverse 1, which is at 90 degrees. So 3x is equal to, where's sine positive, first and second quadrant, right? Cast diagram, first quadrant and second quadrant, that's where sine is positive. So 3x is equal to 90 degrees plus K360. If you divide everything by 3, you got 30 degrees plus K120. But they only wanted an answer between, oh yes, if you do quadrant 2 solution, you should get 180 minus 90, which is 90 plus K360. You'll end up with the exact same answer, right? Because sine of 3x, that is the maximum value, you only end up with one general solution there. So x is equal to 30 degrees plus K120, that's the only general solution. We wanted the answers for x between 0 and 90. So you can clearly see, if I substitute the value of k as negative, it's going to be out of that boundary of 0 to 90. So therefore x is equal to 30 degrees only. Now if you substitute, that's your answer. If I substitute x as 30 degrees in this here, let's see if it makes it an arithmetic sequence. So we got minus 11. Sine of 3 times 30 is 90. Sine of 90 is 1. So minus 11, 2, and 15. So what are we doing each time? We're basically adding 13 each time. So we can see 15 minus 2 is 13. 2 minus 11 is 13. So it makes this arithmetic. Alright, so that's your solution. Perfect, guys. We're doing well. And let's see some good questions here. Right, so we did an arithmetic sequence. Seems like this question is, what is this question? This question is geometric. So let's see, how do we know? Because we are given a common ratio. So what we have here is, if r is equal to 1 over 5 and a is equal to 2000, if r is equal to 1 over 5 and a is equal to 2000, determine t and the general term of the series. So 3.1.1, remember tn is equal to a r to the power n minus 1. We want to find tn, isn't? They already give us a value, which is 2000, right? And the value of r, which is 1 over 5 to the power n minus 1. That's it. You can just leave your answer like that. That's 1 mark. We want to find the value for t7, right? So t7 is equal to substitute 7 in the place of n, getting 2000 into 1 over 5 to the power 7 minus 1, right, which is 6. And either write 607 minus 1, right? So if I enter this on the calculator, what should we get? We enter 2000 into 1 over 5 to the power 6, right? 7 minus 1 is 6. 16 over 125. 16 over 125. Leave your answer like that. Is more accurate. Because if you're going to round off, you're going to get 0,128. Okay, you can write 0,128 as well. It's fine. 3.1.3. Since you're dealing with an exponent here, right, you probably have to solve an exponential equation. Which term of the series will have a value of 16 over 15,625? So which term is solving for n? So you're going to say 2000 into 1 over 5 to the power n minus 1 is equal to 16 over 15,625. Let us solve this equation for n. Right, you should know how to use logs and stuff. So we're going to take 16 over 15,625 divided by 2000, right? So let's see what we're doing. We're doing remember a fraction there and then over 2000. 2000 is going to go in the denominator. So let's enter it like this. Dividing both sides by 2000, and we're getting on top, what are we getting? We're getting 16 over 15,625. If you press equals, you're getting 1 over 195, 3125. But we're getting 1 over 195, 3125. Right? And that's 1 over 5 to the power n minus 1. Therefore, n minus 1 is equal to log of this 1 over 195, 3125, should be 3125, not 27, a mistake here, 3125, yeah, 195, 3125, over log, or you can just say base 1 over 5, log of 1 over 5, right? And we should get an answer. So I can just say log of answer over here. Look at my calculator. What I'm going to do here is I'm just going to say log of the answer, right? So I'm going to say, put the fraction button. I'm going to say log of answer, close bracket, divided by log of 1 over 5. And if I press equals, you're getting an answer of 9. So n minus 1 is equal to 9. Therefore, n is equal to 10. And what did they ask us for? They asked us which term. So you're going to say 10th term. So therefore, T10 is equal to 16 over 10th term is, therefore T10 is 16 over 15,625. 16 over 15,625. Right. Perfect. Question 3.2. Consider the geometric series. We got Tn is equal to 27 and S3, which is equal to 26. Now, whenever you are, see what you are given here, n is equal to 1 to infinity of Tn is equal to 27. So this basically means whenever you are given a series like this, you must always go and open it up and see what you are getting. So you can clearly see this is sum to infinity. So what this is saying is sum to infinity is equal to 27 and S3 is equal to 26. Calculate the value of the constant ratio R of the series. Again, it's a good question, right? Aimed at like level 3 type question. So Yeah, so those are basically cognitive levels. Like you get level 1 type question, level 2 type question, level 3, and level 4. Level 4 is basically the hardest. They usually have about 12 to 15% of the paper is like level 4 questions. Right. Supposed to put level 4 questions, right, in the paper. So this is more like level 3 type question. So what we have here is n is equal to 1 to infinity of Tn is equal to 27. So what can we do here? We can say term 1 plus term 2 plus term 3 plus dot 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 is equal to 27. So basically this is just S infinity is equal to, they said it's a geometric series, so S infinity, what's the sum to infinity formula? A over 1 minus R, right? That's your sum to infinity formula, and that is equal to 27. So we kind of have like an equation here, and the next one, S3 is equal to 26. What is S3? S3, what's your SN formula for your geometric sequence? Your SN formula is basically A into 1 minus R to the power n divided by 1 minus R, right? Now what we are finding is S3, so therefore S3 is now equal to, S3 is equal to A into 1 minus R cubed divided by 1 minus R is equal to 26. Remember clearly that R cannot be equal to 1. So how can we simplify this equation here? So we got equation 1, right, and we got equation 2. If I take equation 2 and divide it by equation 1, see what happens. So if I take equation 2 and if I divide it by equation 1, that's what we usually do when we're solving like geometric simultaneous equation. We need to divide equations. Addition and subtraction, I mean, like, it's quite difficult. So what we're going to do is take equation 2 and divide by equation 1. So we have, for equation 2, we have A over 1 minus R. I'm going to split this up. A over 1 minus R into 1 minus R cubed is equal to 26 all over A over 1 minus R is equal to 27. Now what we can see is clearly some magic happening here. So what we can see here is, we can see that that part and this part is cancelling out, right, one time, right? So if we divide 1 minus R cubed divided by 1 is just, therefore what's the answer? The answer, this implies the answer is 1 minus R cubed is equal to 26 over 27. Right, we got 26 over 27. Take the R cubed over, or you can say minus R cubed is equal to 26 over 27 minus 1. What is should be minus 1 over 27. So what you got? 26 over 27 minus 1, which is equal to minus 1 up, minus 1, which is equal to minus 1 over 27, right? So continue like this. Therefore R cubed is equal to 1 over 27, right? R cubed is equal to 1 over 27. Therefore R is equal to the cube root of 1 over 27. Cube root of 1 is 1 and the cube root of 27 is 3. And remember, for a geometric sequence, the value of R for a geometric sequence, and if it converges, how do we know that the series converges? Because we got sum to infinity, so it has to converge. Since we are given sum to infinity here, right, it converges, and for convergence minus 1 should be between, R should be between minus 1 and 1, and we can see the value of R is 1/3. That is just to check my answer. And if the value of R is 1/3, what's the value of A? Simple, substitute into equation 1. So let me just take this up. So therefore, what was equation 1? Sub into equation 1, right? If I sub this into equation 1, right, what is equation 1? Equation 1 was A over 1 minus R is equal to 27. So A is equal to 27 into 1 minus r. I can just cross multiply, right? I'm just taking the, see, this is equation 1. I'm just taking the 1 minus r over, it's like cross multiplying. 1 times a is a, 1 minus r times 27 is 27 into 1 minus r, right? We had a over 1 minus r is equal to 27, and now we can just enter this in our calculator, where the value of a is 27 into 1 minus 1/3, should get the answer, right? So 27 into 1 minus 1 over 3, right? And that answer is basically 18, right? So the value of a is 18, and the value of r is 1/3. And we can check here, right? Yeah, sum to infinity is 27. You can take 18 divided by 1 minus 1/3, you should get the answer of 27. Perfect. Good question, guys. Right, let us have a look at question 4. Yeah, so what do we have in question 4? Right, in question 4 we have the lines y is equal to x plus 1. Okay, looks like we have functions, which is a hyperbola type question. Right, so we got the lines y is equal to x plus 1 and y is equal to negative x minus 7 are the axes of symmetry of the function, right? Very nice question, right? Very seldom we see good questions like these, right? So it's like aimed at like level 3 types, right? Are the axes of symmetry of the function f of x is equal to minus 2 over x plus p plus q. Now how do we get the axis of symmetry? We need to look at show that p equals 4 and q is equal to minus 3. So 4.1, axis of symmetry, we go in this pattern over here, right? And we cut it half. So remember, there are two axes of symmetry for the original hyperbola, which is y is equal to x plus p plus q, or y is equal to x with a minus, is basically the same thing over here with a minus on the outside, minus into x plus p plus q. You will put the minus in the denominator and just add the q, right? Now this one just becomes x plus p plus q, right? Y is equal to x plus p plus q, or y is equal to negative x plus negative x minus p, negative x minus p plus q. Now we know that x plus p plus q is equal to x plus 1, so we can just equate this to x plus 1, and we can equate the second one into minus x minus 7. See what happens now. This one simplifies into an equation, and the other equation, and the second one also simplifies into an equation. This is the positive axis of symmetry, right? And this is the negative axis of symmetry. Don't forget that. Positive because it's plus here, right? The gradient is positive. So we can see that x and x cancels out. So what we have is, therefore, p plus q is equal to 1, or we can see the minus x and the minus x cancel out. So what we have here is minus p plus q is equal to negative 7. So we can just take this equation and add both. So we have p plus q is equal to 1. So we're using method of elimination, right? So if we add up both these equations, minus p plus p cancels out, q plus q is 2q, minus 7 plus 1 is minus 6. Therefore the value of q is equal to minus 3. Did they want the value of q as minus 3? Perfect. Value of q is minus 3. So what's the value for p? P is equal to 1 minus q, 1 minus minus 3, which is 1 plus 3, which is equal to 4. So the value of p is 4 and the value of q is equal to minus 3. So that's your solution. You showed it. Calculate the x-intercepts of f. Now since we have p and q, enter it there, right? Enter it in the function. Let's insert some space here. Yeah, so what's the value of P and Q. So minus 2 over, we're going to write the function down. So y is equal to, the f is a function y is equal to minus 2 over x plus 4 minus 3, because the value of P is 4, right, and the value of Q is minus 3. So minus 2 over x plus 4 minus 3, x plus 4 minus 3, right, sorted. We're going to find the x-intercepts. So x-intercept, remember you need to make y equal to 0, so 0 equals minus 2 over x plus 4 minus 3. Solving this equation, we can take this minus 2 over x plus 4 on the left hand side, right. So if you take this over, you're getting 2 over x plus 4 is equal to negative 3, right. And if I cross multiply, right, make it over 1. If I cross multiply, I've got minus 3 into x plus 4 is equal to 2. We're finding the x-intercept. So what we have is minus 3x minus 12 is equal to 2. Minus 3x is equal to, taking that over, should get 14. Therefore, x is equal to minus 14 over 3. So did they want a coordinate or just wanted the x-intercept? So calculate the x-intercept of f, right? So x-intercept of f, you can write it in coordinate form, is better. So x-intercept is minus 14 over 3 and 0. You can write this as a decimal value. We can write negative, see, 14 divided by 3. You can say that is 4,67. It'll be nice, it'll be good to know this value in decimal form, right, because for sketching purposes, right, minus 4,67. And that's sorted out. What's the next question? Sketch a graph of f. Clearly label all intercepts with the axes and the asymptotes. So obviously we need the horizontal, vertical asymptote and sketch the graph. So 4.3, we're going to sketch the graph. Simple. Remember, we also need the y-intercept for sketching the graph. So 4.3, sketching the graph. Let me insert some axes here. Right, so here's one axis here. Remember the graph is in the second and fourth quadrant, because y is equal to minus 2 over x plus 4 minus 3. So the vertical asymptote is making the denominator equal to 0. The vertical asymptote is x is equal to minus 4. The vertical asymptote is at minus 4, right. I like to draw my vertical the asymptotes in broken lines. So let me just break up this line, right, and this is x is equal to minus 4. That's my vertical asymptote. My horizontal asymptote is equal to minus 3, right. So go to minus 3. Change the color of this graph, right. So minus 3, so y is equal to minus 3, right. X is equal to minus 4, y is equal to minus 3. That's 0, x-axis, that's the y-axis. Remember, my graph is in the second and fourth quadrants, right. So my graph is in the second and fourth quadrant. So let's extend this a bit. Second and fourth quadrant, that's where my graph is in. I extend this line as well. So it's going there. I need to break up this line as well. It's an asymptote, so right? So, and remember my x-intercept was minus 4,67, and that's minus 4, that's minus 3. So one piece of the graph, let me just neaten it up. And so that's minus 14 over 3. Yeah, what's my y-intercept? You need to make x equal to 0. So you're getting minus 2 over 4. Right, so what's my y-intercept? My y-intercept is basically minus 2 over 4 minus 3. So you're getting minus 7 over 2, which is minus 3.5. Minus 3.5 is just about there. One graph is there and one graph is here. And we just shift as x equals minus 4 on the other side. You just write it here, x is equal to minus 4, vertical asymptote, right? And then sketching this graph, coming there and going down here. So that should be a graph in the second and fourth quadrants. Remember, what makes the quadrants are asymptotes of the hyperbola that makes the quadrants. Example, this is the asymptote, horizontal and vertical asymptote, and there's quadrant 1 here, there's quadrant 2 here, there's quadrant 3, and there's quadrant 4 here. So the graph needs to be in quadrant 2 and 4. You can clearly see because of the x and y intercept as well, that proves it. Right, so that should give you full marks. Right, guys, good question on hyperbola. Right, no, nothing, just the first question was a bit tricky because you needed to remember your rules, but they already gave you P and Q, so there's no excuse to get the second and the last question wrong. Let us move on to question number 5. Right, so in question number 5, what we have here is a parabola and a line. So this is like more like a compulsory question, so make sure you always learn a parabola and a line. Basically comes out like in 90% of the papers, final papers. Right, this is the supplementary paper we're solving, by the way. It's good revision for trials and final exam. Right, so sketch below are the graphs of f of x and g of x. So the entire equations are given, so there's nothing difficult here. A and b are the x-intercepts and c is the turning point of f. So it looks like a is a common x-intercept for both. They should have said a is a common x-intercept. Alright, so we can find the coordinates of the x-intercept of g, and then we can see whether it is common or not. Right, so anyways, let us answer the question. Calculate the coordinates of a and b. A and b are the x-intercepts, so you need to make y 0, so 5.1. Right, I'm just going to do it on this side. Alright, see. So we're finding x-intercept, make y 0. So remember the equation is minus 2x squared plus 4x plus 16 is equal to 0. Remember to make y equal to 0 because we are finding the x-intercept. So there's my y, which is 0. It's supposed to be on this side, but I just shifted it there. Now, if you solve this equation, making it standard form, x squared minus 2x minus 8 is equal to 0. You see 4 and 2 is working out. So x minus 4, x plus 2 is equal to 0. Minus 4 plus 2 is minus 2, minus 4 times 2 is, so x is equal to 4, or x is equal to minus 2. So we can fill in minus 2 here and 4 there. So coordinates of a is minus 2, 0, and okay, let's write the corresponding coordinates. So this is coordinates of b, and so I ended up doing b first. B is 4, 0, and a, coordinates of a is minus 2, 0. Sorted out, minus 2 and 4. Next one, determine the coordinates of c, the turning points of f. Right, so 5.2, you can use calculus. Right, you can find the derivative and set it equal to 0, or you can use minus b over 2a and solve. Let us just use calculus. Remember, y is equal to minus 2x squared plus 4x plus 16. So if I find y prime and set it equal to 0, we should get the x value of the turning point. So minus 4x plus 4 is equal to 0. Therefore, x is equal to, if I take the 4 over, we get minus 4 divided by minus 4. Minus 4 divided by minus 4, which is 1. Or you can take the x-intercepts and divide it by 2 in this case. So 4 minus 2, which is 2. 2 divided by 2 is 1. So the coordinates of C is 1 at the moment so far. And to get the value for x, you can just substitute inside here. So the y value is, we're substituting 1 inside here. So minus 2 plus 4 plus 16, that is 20 minus 2, which is 18. Right. Or you can just show it on the calculator, just to show it. Right. Let me show you what we're doing. Saying minus 2. Right. So I'm not going to substitute 1 here. 1 squared is 1, guys, and 4 times 1 is just 4. Plus 4 and plus 16. What we're getting? 18. Right. So that is correct. So what's the coordinates of C? 1 and 18. Right. So that's the coordinates of C. Now 5.3, write down the range of f. Now since you have the coordinates of C, right, which is 1 and 18, what's the range? The range is y values. Where is the graph sketched? So it's from 18 downwards. That's where the, remember the maximum value is 18. So y is less than or equal to 18. So y is less than or equal to 18. Simple question. Where's the range? Put some space here. Right. Okay, 5.4. Let's look at 5.4. The graph of h of x, right? So probably see what they're asking us here. So this is a different graph. The graph of h of x, which is f of x plus p plus q, has a maximum value of 15 at x is equal to 2. Determine the values of p and q, right? So they took the graph of f and they have shifted it around, right? Let's see. So what is the graph? To answer this question, we need to write the graph of f in turning point form. So the graph of f, 5.4, right? So let's analyze the graph of f. Graph of f can be written in turning point form. How? Because we got the maximum value 1 and 18, so we can just say minus 2 into x minus 1 all squared plus 18, because remember the turning point is 1 and 18. So if you take the opposite sign from here, you get 1, take 18. If you try substituting 0 inside here, you should get the y-intercept. Or if I substitute 0 inside here, you should get minus 2 plus 18, which is 16. Is the y-intercept 16? Yeah. So that is your graph of f in turning point form. So that's the graph of f in turning point form. Now this one here is telling me has a maximum value of 15. It has a, see, the other graph has a maximum value at x is equal to 2, right? So in order to have a maximum value of 15 at x is equal to 2, you can find the value of p and q from here. But this is saying f of x plus p. Right, so this is f of x, right? So if I try to find f of x plus 1, what will I get? That's not working out. If I try to say f of x minus 1, f of x minus 1. If I say f of x minus 1, over here what we're getting here, because I'm trying to get minus 2 inside this bracket here, we're going to get minus 2 into x minus 1, because remember, if I say f of x minus 1, right, I need to substitute x minus 1 in the place of x. So what are we saying? So we substituted x minus 1 in the place of x, then minus 1 all squared plus 18, right? That is f of x minus 1. And then to get h of x, you can say, now you can simplify this, so you can say minus 2 into x minus 2 all squared plus 18 minus 3. 18 minus 3 should give me 15. Yeah. So what are we doing here? So basically what we're doing here is f of x plus p plus q. What is f of x plus p? F of x plus p is basically this part over here, right, which is f of x minus 1, rather f of x minus 1. And yeah, so basically what we're doing, we can just have a look at this part over here. Yeah, should be fine. Just trying to think that this is right. So this is basically right, so if we take away minus 3, that's fine. But what is this entire thing over here? This is basically f of x minus 1, right? That's f of x minus 1, and you just need to say minus 3. So the basically, guys, a very tricky question, right? So the value of p, therefore value of p should give me minus 1 because we're comparing to here, and value of q should be minus 3. Yeah, the value of p should be minus 1 and value of q should be minus 3. Is there any other way that we could have worked it out? Because they said maximum value is 15, we kind of shifting this graph 3 units down, right, to get maximum value. So shifting this graph 3 units down, so minus 3. And because they said x is equal to 2, remember the new coordinate is 2 and 15. So we kind of 2 and 50, we kind of taking this graph of f and shifting it 1 unit to the left. So yeah, not actually 2 units, right? So taking the graph of f and shifting it 1 unit to the left, or no, sorry, 1 unit to the right. Yeah, because at x is equal to 2, correct. So your correct solution should be minus 1, p is minus 1 and q is minus 3, correct. Let's look at 5.5. If you have any confusion, let me know in the comment section. All right. Determine the equation of g inverse, the inverse of g in the form y equals. So what's the graph of g? So the graph of g is y is equal to, that's a straight line function, right? And its straight line function is 1x value, 1y value, it is 1 to 1, so 2x plus 4. So the inverse does exist, 2x plus 4. Remember, an inverse of a parabola does exist provided it needs to be restricted. You must have a restriction on the x for a parabola, then only you can find the inverse. Right, so this is a straight line function. It is a 1-to-1 function because if you use a horizontal line and a vertical line test, it cuts the graph once only. Right, let's see g. So what is g inverse? G inverse is we switch the x and the y, so x is equal to 2y plus 4, and then we solve for y. So we're going to say, right, so 2y is equal to x minus 4. Therefore, divide everything by 2 or multiply by half. So y is equal to half x minus 4 divided by 2, which is minus 2. Right, so what form did they want it in? Determine the equation of g inverse in the form y equals. So y is equal to half x minus 2. 5.6. 5.6 is asking us for which values of x will g inverse x times g of x be equal to 0. G inverse x times g of x be equal to 0. So we're going to take g inverse x times g of x is equal to 0. Just use the algebraic method because they didn't really specify whether we should use the graph. There is a way to use a graph. Where's g inverse x times g of x is equal to 0? Either g inverse x is equal to 0 or g of x is equal to 0. That's what this basically means. So either g inverse x is equal to 0 or g of x is equal to 0. Right, so when is g inverse x equal to 0? You can just say half x minus 2. When half x minus 2 is equal to 0, if we solve this equation, so we are just looking for the x-intercepts, guys. X-intercepts of either g of x or g of x, g inverse x or g of x. Right, so g inverse x is half x minus 2. So you got half x is equal to 2, and then cross multiply, x is equal to 4. Right, half times 4 is 2 minus 2, which is 0. That's correct. And then g of x, what is g of x? G of x was this function 2x plus 4. So 2x plus 4 is equal to 0. So therefore x is equal to minus 4 divided by 2, which is minus 2. So these are our two solutions. These are our two solutions, which is x is equal to 4 or x is equal to minus 2. Let's look at the next question. 5.6. Yeah, 5.7, guys. If p of x is equal to f of x plus k, I just want to write it inside here. Right, so p of x is equal, so that's 5.7. I'll cut it out and paste it at the bottom. P of x is equal to f of x plus k. Right, so this is more like a level 4 type question. It's a bit challenging, but it did come out in past papers, guys, so it shouldn't be difficult. And so p of x is equal to f of x plus k. Right, now what they are asking us here, if p of x is equal to f of x plus k, determine the values of k for which p and g will not intersect. Right, so at the moment it does intersect. Right, you can see it's intersecting at 2 points. The only way that it will not intersect is if this graph is basically somewhere around there. Yeah, but that's not the way to solve. At the moment it is intersecting, we are getting real solutions. So what we need to do over here is, when will it not intersect? When the roots are non-real. Remember, we need, this is a question where you actually need to go and use delta. Will not intersect. If it does intersect, it has a solution. So when will the graphs not intersect? It will not intersect when delta is less than 0, because delta less than 0 means non-real roots, and then it will be simple. Right, so that's what we need to look at. It will not intersect when roots are non-real. It will intersect if its delta is greater than or equal to 0. So we cut this out, and 5.7. Right, so 5.7, nice question again. Right, so p of x is equal to f of x plus k. So what is f of x? F of x is basically minus 2x squared. We did have that. We had minus 2x squared. What is f of x? F of x function is, they told us, it is minus 2x squared plus 4x plus 16. Let's just double check that. Minus 2x squared plus 4x plus 16. Plus k, right? For which values, for which p and g will not intersect? P and g, right? So this is p, and let's equate it to g. Right, so p and g, this is p here, that is f and g, this p and g. So let's intersect it and then find delta, which is less than 0, right, which is equal to g of x is 2x plus 4. 2x plus 4, right? P and G, right? Remember, P and G will not intersect, because remember, to find the nature of roots we need an equation, and this was just giving us an expression. Then it does not need to intersect, mustn't intersect here. Let's see. So if we bring everything over, we're getting minus 2x squared, 2 plus 2x, 16 minus 4 is plus 12, plus k is equal to 0. Now we kind of got an equation. So we have minus 2x squared. Let's just double check this, take this over. Correct, 4x minus 2x is 2x, 16 minus 4 is 12, and k is equal to 0. Writing this in standard form, we got x squared minus 2x minus 12 minus k is equal to 0. So there's a value of a, which is 1, value of b is minus 2, and this entire thing over here is the value for c, which is minus 12 minus k. Therefore, we're going to find delta, which is equal to b squared minus 4ac. We need to make it less than 0. What is b squared minus 4ac? Because if delta is less than 0, then it will not intersect. Right? In other words, you got non-real roots. So b squared minus 4ac is less than 0. B squared is minus 2 squared minus 4. A is 1. C is minus 12 minus k. Should be less than 0. I think we're just solving a linear inequality here, so it shouldn't be difficult to solve this. But the concept is important, guys. Right, so what we have here is 4 minus 4 times minus 12 is plus 48. And minus 4 times minus k is plus 4k, less than 0. Now, if I take this over, we got 4k, which is less than, this is 52, so minus 52. We're not dividing by negative, so no need to change the sign. Therefore, k is less than, minus 52 divided by 13, divided by 4, sorry, should give you 13. So let's use a calculator. Minus 52 divided by 4 should give me minus 13. So for all values of k less than minus 13, the graphs of p and g will not intersect. Determine the values of k for which p and g will not intersect. So values of k are less than 13. So if you take any value less than minus 13, example minus 12, right, if you take the value of less than minus 13, just say minus 14. If you take the value of k as minus 14 and substitute inside here, let's just check if that thing actually works, right? So I'm just going to use the equation solver. If you do have this calculator, is great, right? It really saves time in certain things, certain understanding. Example like this question here, number 3. I'm trying to test whether if my solution is correct. So if I substitute 1, there's it here. Value of a is 1, b is minus 2, and value of for c is minus 12, minus, open bracket. I said I'm taking an answer of, remember it's minus 12 minus k. I'm taking the value of k to be minus 14. Right, and I'm going to press enter. So it's just basically 2. See, I'm getting non-real roots. In other words, it will not intersect. So this answer is definitely correct. Well, you can check for other values of k less than minus 13, like maybe closer to minus 13. Right, so let us have a look at question 6. Let's insert some space here. Right. question 6.1.1. Right, what is this question about? Write down the equation of G inverse in the form y equals. So we have an exponential function, right? So obviously the inverse will be a log function, and it's a straightforward function, not difficult. Right, so 6.1.1, G is a function y is equal to 3 to the power x. Now when you're finding G inverse, you need to swap the x and the y, right? So G inverse is equal to x is equal to, you see, y becomes x and x becomes y, 3 to the power y. After you swap the x and the y, what you do is you solve for y. Therefore, y is equal to log x, and the base just remains the base, right? Base 3, log x base 3. And that's your answer. And just for 2 marks. Remember, the restriction for x has to be greater than 0. Log of a negative number is not defined. 6.1.2, point P 6 and 11 lies on edge of x, which is, let me shift this to one side and see, because we're talking about the graph which I've just sent down here. No, it's a new question. Okay, let me just open the exam paper and see. There's question 2, looking at question, alright, so finish all this is done. Question 5 is done, right? Looking at question 6 here, right? So write down the equation of G inverse in the form, right? So this is part of the same question. Let's see. So they're telling us that point 611 lies on h of x, which is 3 to the power x minus 4 plus 2. The graph of h is translated to form G. Write down the coordinates of the image of P on G. Right, so we need to draw some kind of picture, right? So point P, which is 611, lies on h of x. Now, what's happening with the graph of G and H? What did we do with the graph of G and H? How did we transform from G to H? 6.1.2. The way we transform from G to H is we shifted the graph of G 4 units to the right. So that's the reason why it is x plus 4. So shifted the graph 4 units right and 2 units upwards. Plus 2. We shifted the graph of G 4 units to the right and 2 units upward to get the graph of h of x. That's what my rule is at the moment. That's what I have done to the graph of G. 4 units to the right, so it became x minus 4. Yeah, it basically takes opposite sign. If you shift left, then you have to say plus, right? At the moment it is, and for the y value just plus 2. That's what happened. And point P lies on this graph. So point P lies on this graph. You can check it up. You can substitute 6 inside here. 6 minus 4 is 6 minus 4, which is 2. 3 squared is 9. 9 plus 2 is 11. So P does lie on this. The graph of H is translated to form G. Right. So the graph of H is translated. So now obviously if you're translating the graph of H to form G, then you kind of like you have to minus 2 now. You just reverse this rule. Right, so what we're doing is reverse this rule here. So you want to go from H to G. So we already got the rule from G to H. So if you want to go from H to G, what you're going to do? You have to, the rule is minus 4 and minus 2. So if you minus 4 and if you minus 2, then you will get the graph of g of x, right? Then if you get the graph for g of x, remember point P, we need to do the exact same thing for point P. We need to minus 4 units from here. Therefore, the image of P is, if I subtract 4 units from the x value, I should get 6 minus 4 and 11 minus 2. So P prime, the image of P, which is, let's call it P prime, right? Image of P, which is 2 and 9, and you can clearly see 2 and 9 does lie on G, because if I substitute it inside this equation, 3 squared is 9. So this is definitely correct. So all you needed was just this point here, 2 and 9, that's all. You can just write this final answer down. This is just my explanation, right? Now next question, which is 6.1.2, is done. Now let's look at the next question, which I have it down here. To save time, cut it out. Right, so sketched is the graph of f of x, which is 2 to the power x plus p plus q, and t, which is 3 and 16. Let's make this thing a bit smaller. Yeah, that's perfect. Right, so sketched is a graph of f of x, which is 2 to the power x plus p plus q. You can clearly see it's an exponential function. Right, these types, it's an exponent. You can clearly see it's an exponent, so it's an exponential function. The value of q is actually here, which is the horizontal asymptote. So we already got the value of q, which is minus 16. T is a point, 3 and 16 is a point on f, and the asymptote of f is y is equal to minus 16. That is the value of q. Remember, what type of asymptote is this? It's a horizontal asymptote. An exponential function only has an horizontal asymptote, so that is the value of q. Determine the values of p and q. Easy peasy. We got the value of q. You can just write value of q is equal to minus 16, and substitute this point t, which lies on this graph of f. Right, this point t, which lies on the graph of f. So you're going to say f is a function y is equal to 2 to the power x plus p minus 16 at 3 and 16. Right, so we're going to say 16 is equal to 2 to the power 3 plus p minus 16. You can take this minus 16 over. You can say 32 is equal to 2 to the power 3 plus p. You got two options. You can either use log, or you can say 2 to the power what is 32. Right, so you can use logs. You can say log 32 base 2. You can end up with 5 as an answer, and then 3 plus p is equal to 5, p is equal to 2, or just write it like this: 2 to the power 5 is equal to 2 to the power 3 plus p, because 2 to the power 5 is 32. If you want to see how we do it on the calculator, you can use that fact. That's what it has, a nice, you can even prime factorize 32. You say 32 equals, and press shift, and there was some fact over here where it gives you a nice, yeah, shift fact. See this degrees and this time button over here. Alright, so 2 to the power 5 is 32. So it does the prime factorization for you, right? So you can drop the base now because you got same bases, right? And then equate the powers or the indices. Therefore 5 is equal to 3 plus p. Therefore p is equal to 2. So value of p is 2 and the value of q is 16. And we are done with this question. All right, so looking at the next question, which is question 7, which is financial maths. Right, so an amount of 10,000 Rand was invested for 4 years, earning interest at R% per annum compounded quarterly, right? At the end of the 4 years, the total amount in the account was 13,080. Determine the value of R. So I like to draw a timeline to say that, alright, an amount of 10,000 Rand was invested. I'll just put 10K to represent K as 1,000. Was invested for 4 years, so 0 to 4, and obviously we're getting some future value amount here. The total amount in the account was 13,080. Remember, this timeline is in years, so this is 13,080 after 4 years. And R% per annum compounded quarterly. Remember, the interest rate is in quarters. The total amount in the account was, right, so Remember the formula, you can take it out from the formula sheet. A is equal to P into 1 plus I to the power N. Now A is already 13,080. Principal is 10,000 rands. 1 plus I. What is I? R over 400 to the power 4. Right? Times the number of years. The number of years is 4. Right? That's how you need to work it out. Because compounded quarterly, sometimes people write R over 100 divided by 4. Well, this is the same thing as saying quarter into R over 100. That's how I got R over 400. So if I'm dealing with a monthly rate, just say 10% per annum compounded monthly, I'll say 10 over 1200. Right? Compounded half yearly, if I'm dealing with that, then I'll just say like 12 over 200 compounded half yearly. Yeah. So compounded quarterly is the same thing as saying compounded every 3 months. All right. So 4 times 4, right? So 4 from here, right? And times 4 because this is the number of years. And you can see you need to put it to the power 16 because 4 years is 16 quarters. Now 13,080 divided by 10,000, you should get the answer of 1,3080. If you take 13,000, right, let's see. I think we should actually just solve for, make R the subject of the formula and just solve, right? So what we're getting is 13,080 divided by 10,000, right? Which is equal to 1 plus R over 400 to the power 16. Now to get rid of the 16, we can take the 16th root or just multiply by the reciprocal of that, 1 over 16 on this side and to the power 1 over 16 here. So the answer, what does this here become now? 16 and 1 over 16, that cancel out. So you got 1 plus R over 400 is equal to 13,080 divided by 10,000 to the power 1 over 16. So obviously in this case we are going to get some answer. So what answer are we getting? What answer will we get? So you got open a bracket here. Remember to subtract 1 and multiply by 400. So you got 13,080 over 10,000. Right, I'm just entering that in my calculator. Right, hope you can see clearly. Over 10,000, close bracket, to the power 1 over 16. Right, I will get some answer over here. Then I need to subtract 1. Right, I will subtract 1 and then multiply it by 400. Then times 400, and I'm getting an answer of 6,769. So 6,77%. 6,77%. Make some space here. So what we have done is to get the value of R, 13,080 over 10,000 to the power 1 over 16 minus 1, right, and times it by 400. So what we have, R is equal to 6,77%. Yeah, 6,77%. That's your answer for R. That's what we needed. Let's just double check. Determine the value of R. Yeah, R percent per annum. Let's look at 7.2. So what we have here in 7.2 is, see, I hope it's an annuity problem. Let's see. A businesswoman deposited 9,000 Rand into an account 9,000 Rand into an account at the end of January 2014. She continued to make monthly deposits of 9,000 Rand at the end of each month up to the end of December 2018. The account earned interest at a rate of 7.5% per annum compounded monthly. So if you count from January 2014 to December 2018, you should get 5 years, because January 2014 is, you can't just say 2018 minus 2014 because you're missing out an entire, let's see. So 2014, entire of 2014, 2015, 2016, 2017, 2018. So you are getting 5 years. So if you have to look at this scenario, what she is doing is, if I draw a timeline and just look at what she is doing, businesswoman deposited 9,000 Rand, 9,000 Rand here, so just put 9k here at 1, right, that's 0. So basically that's 5 years in total. That's what we have calculated. At the end of December 20, so this is going to be 5 times 12, because at the end of every month that's 60 months, right? So let's get this timeline right, correct. So that's 60 months. She deposits 9k at the end of each month. Interest rate is 7.5% per annum compounded monthly. Make sure the interest rate and the timeline corresponds. The monthly payments with the monthly interest rate, yearly payments with yearly interest rate. Otherwise, if the interest rate is different to your timeline, then you have to go and use nominal and effective interest rate formula to calculate the appropriate interest rate. At the moment it is all correct. So the interest over here is 7.5% per annum compounded monthly. So 7.2.1, calculate how much money was invested in the account immediately after the 60 deposits has been made. Calculate how much money was in the account immediately after the 60th deposit has been made. So basically, guys, we are calculating the future value, right? So future value annuity is an annuity because it's on a monthly basis. 9k here and continues to do so. So we want to know the amount at the end. So future value annuity, I think we use an f, x into 1 plus I to the power n minus 1 divided by an I, right? X is 9,000 Rand, 1 plus 7.5 over 1200, right, to the power 60, because n is the number of months, right? You're starting at 1 and you're ending at 60. If you count from 1 to 60, here's 60 months. Minus 1 divided by 7.5 over 1200. 1200, that should be, should be over 1200. And we should get an answer over here. Let us enter all this in the calculator. So welcome back. There's some technical issues, right? So we're entering this in the calculator, this entire big thing over here. So you can say 9,000 into put another bracket, 1 plus 7.5 over 1200 to the power 60, subtract 1, close bracket, divided by 7.5 over 1200. We're getting an answer of 652,743, comma 9479, which is approximately equal to 652,743, comma 95, right? Next question. Yeah, just to check that, let's see what's 9,000 times 60. So if you see 9,000 times 60, so this person actually deposit 540,000, so she should get extra because of the interest rate. Let's look at 7.2.1. The businesswoman left the amount calculated in 7.2.1 for a further n months, right, in the account. The interest rate remained unchanged and no further payments were made. The total interest earned over the entire investment period was 190,214.14. The total interest earned is just the interest earned over the entire. The total interest earned over the entire investment period was 90. So this is a new investment. So what we're doing now is new stuff. So 7.2.2. So she left this money in the account. So she invested kind of 652,743.95 at 0. And obviously the future value of this investment is 652,743.95 plus the interest earned, remember, plus the interest earned over this entire period was they're giving us that amount 190,214.14, 190,214.14. So that amount is, let's see, 652,743.95 plus 190,214.14. I'm getting an answer of 842,958.09. So we got our present value, future value sorted out, accumulated value sorted out, and the interest rate was just 7.5% per annum, compounded monthly. Remember, this is n is in years, so we're going to see what they want. Determine the value for a further n months. Okay, let's make n in months. So let's just say n is in months. N months, right? So we can just say to the power n. If you said n was in years, then you have to say to the power 12. And let's see. So a is equal to p into 1 plus I to the power n. Now remember, we're already dealing in months, so we can just say to the power n. So a is 842,958,09. Is it 09? Yeah, is 09 is equal to p 652,743,95 into 1 plus 7.5 over 1200 to the power n, which is in months. When we calculate n, we'll end up calculating in months. So we're going to take this and divide by this. So you can say 1 plus 7.5 over 1200 to the power. Do we get a nice answer for 1 plus 7.5 over 1200? Let's work it out. 1 plus 7.5 over 1200. We're getting 1 point. Okay, no, it's fine. Let's just keep it at 1.7. Now let's take 842,958. We need to divide it by this because solving for n, we're going to end up using logs. So let's move the calculator one side. Right, so let's see. Let's put the calculator on. So you're taking 842,958.09. 842,958.09, and you're dividing by 652,743.95. you press equals, you're getting 1.2914. Take more decimals, 1,2914, because we have to end up using logs. 0.7, take 6 decimals. Therefore n is equal to log of this, log of 1,291407 divided by log of this here, log of the base, log of 1 plus 7.5 over 1200. So if you solve this, you're going to say, put a bracket, so put a fraction, say log of answer, that previous answer was already stored in there, divided by log of 1 plus 7.5 over 1200, and we should get our number of months. So 41,04 months, 41,04 months. What if you took log of 1,29? Just see, let's just say what happens if you just take 2 decimal place on that side, log of 1.29. If I say log of 1.29, what do I get? Log of 1.29, getting 40,86. So you can say approximately 41 months, right? Let's see, determine the value of n. Total interest earned for a further n months in the account. The interest rate remained unchanged and no further payments were made. The total interest earned over the entire investment period was 190,214. The entire investment period is this one. The interest rate remained unchanged and no further payments were made. The total interest earned over the entire investment period. I'm just thinking whether if the entire investment period should be the previous period as well. Okay. Because they didn't specify over here. So this is for this period only, but since they said the entire investment period should be the previous 5 years, so I'm going to put both the solutions down, and I think it's more likely this solution over here. So let's see, for the n months, further n months, and this previous investment period as well. That's what they mean by the entire investment period. Quite ambiguous. Okay, let's work it out. Let's work out this other one as well. Entire investment period, is looking at the annuity period as well, the previous period as well, not the current period. So entire investment period will be basically the previous 60 months plus not these months here. We don't know. Obviously the answer for n will be different in this case. So we need to look at the total amount over here. The future value over here was 652. What was it? Yeah, the future value was 652,743.95. Just want to copy this down from here, and that was the future value. Right, so remember, this is the value of the investment she's making now, right? So I want to know what's the interest earned on this one. What's the interest earned on this one? Is going to be minus 9,000 times 60, because she made 60 payments of 9,000. So you're going to work out 652. So 652 743.95 minus 9,000 times 60. if I get an answer of 112,743, comma 95. But now the total interest, so total interest earned is equal to 190,000. That's what they're saying. 190,214,14, 214,14, 214,14. So the balance of the interest will be made if we invest this money for further n months. So if you subtract these two, so interest balance, right? So the balance of the interest will be made for the time. So you're going to take 190,214. So let's just take this answer. Let's take this answer over here, right? And this is subtract 190,214.14. So 77,470 77,470, comma 470, comma 19. So basically I've took this and I subtracted this for the new timeline. So what's happening here is that I'm investing an amount of 652,743,95, and my future value is this plus the balance of the interest. Remember, I've already subtracted from the total interest what I've made in the previous 5 years with my monthly 9,000 Rand deposits. So I can say 0 to n months here. So let's see, 652,743.95 plus this amount over here. Let's just highlight this amount. This amount plus the 652 should give you the future value here. So I'm going to take that, let's multiply by -1 to get a positive answer. So 7740.19, right? I've got that amount saved already, plus 652,743.95. So my future value is 730,214, comma 730,214, comma 14. Now I can use the same formula as before. So A is equal to P into 1 plus I to the power n. Right, so principal value is 652,743,95 into 1 plus 7.5 over 1200 to the power n is equal to A. What's the value for A? 730,214,14. How I got this value of A again? Remember, on the annuity I made an interest rate of, on that monthly payment that I was making at the bank, I made a total interest of 112,743, and the total, and I took this amount and I invested for further n months, and I made 77,470 Rand and 19 cents. How I got this? I took the total interest minus the interest from the annuity. I got 77,470.19. So that's the interest made. There's it here, 652,743.95. I take this amount and that amount, add it up, and I get 730,214,14. And now I'm putting this in the formula to get the answer for n, for how many months do I invest. So if I take this answer and divide by that answer, we should get, let's see, so 730,214.14, 730,214.14 divided by 652,743.95. and I'm getting 1,1186. 1,1186, put more decimals there, 84, right, is equal to 1 plus 7.5 over 1200 to the power n. So n is equal to log of this. N is equal to log of 1,118684 divided by log of 1 plus 7.5 over 1200. And if I solve that, if I say log of, remember, put this, what is answer? Let me see if my answer is still stored. Let's say answer equals, yeah, my answer is still stored. So I can say log of answer, close bracket, divided by log of 1 plus 7.5 over 1200, close bracket. I'm getting an answer of 18, approximately 18 months. Yeah, yeah guys, I think this is more accurate answer, so leave out the previous one. Yeah, kind of ambiguous, because they should have said for this period only, but because they said for the entire investment period, the entire investment period is made up of your previous annuity plus the current investment period. So I'm going to take out this solution over here. Yeah, I should take out this solution here, right? Should work with this one here. Just select this one, makes more sense. Entire investment period. Right, let's see next few questions. Right, so question 8, we have calculus here. Right, pretty straightforward, nothing's difficult here. Let's see how we solve it. Okay, so we can find f prime x for first principles if it is given that f of x is equal to 3x squared. So 8.1, first principles formula, you're going to say f prime x is equal to limit, you can just copy this from your formula sheet, f of x plus h minus f of x all over h, right? Now what is f of x plus h? Limit as h approaches 0. F of x plus h is in the place of x. Wherever you see x in f of x, you need to substitute x plus h. So replace the x with x plus h. So we got 3 into x plus h all squared. You can see I've replaced the x with the x plus h minus 3x squared, because that's what f of x is. If there were more terms, you'll put a bracket all over h. Now carry on solving this. So limit as h approaches 0 of 3. Open this up. We got x squared plus 2xh plus h squared, which is squaring a binomial, or you can do products, right, in this idea, minus 3x squared all over h. How you square a binomial? You square the first term, which is x squared, you square the h, which is h squared. The middle term is the product of these two terms, x times h, which is xh, and double it, so you get 2xh. Now if you open all this up, getting limit, right, as h approaches 0, just neaten this up. Right, so what we're getting is limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 3x squared all over h. What you will notice that your f of x function always cancels out, right? So you can see 3x squared and minus 3x squared cancelling out. Then what we have here is limit as h approaches 0 of, you can factorize this, you can take out h as a common factor, you're left with 6x plus 3h yeah, 6x plus 3h all over h. Now what happens is that your h and your h cancels out, and if I substitute, if you simplify this limit as h approaches 0 of 6x plus 3h, what's the answer we're getting? Remember, h is 0 now, that is 0, so you're just getting 6x. And if I differentiate 3x squared like normal with the rule, 2 times 3 is 6, 6x, subtract 1 from the power, 2 minus 1, so you get 6x, which is correct. And that's your final answer, which is your f prime x. That's what they asked us for. Right, next question, we want to find f prime x if f of x. So let me just write it here and take it down. 8.2.1. 1 second. We got x squared minus 3 plus 9 over x squared. I'll just cut this out and take it down. That's 8.2.1 f of x, and find f prime x. So 8.2.1. So remember, this is f of x. So let us find f prime x. We can't find f prime x because we need to put everything in terms of powers. So f of x is equal to x squared. I think there was a minus 3. Was it minus 3 or minus 3x? It was minus 3. Okay, great. Minus 3 plus 9. If you shift the x squared up, it's going to become x to the power minus 2. Right, now let us differentiate using rules. F prime x is now equal to 2 times 1, which is 2x. Subtract 1 from the power. Derivative of a constant is 0. And 9 times minus 2 is minus 18. X to the power minus 3. Get in the habit of writing it in terms of positive exponents. So you got 2x minus 18. X to the power minus 3 shifts down, becomes x to the power 3. So write in positive exponents. Get in the habit of writing it like that. 8.2.2. Right, 8.2.2. Let's have a look at the question. 8.2.2. We've got root x plus 3. So g of x, root x plus 3 into root x minus 1, that is g of x, and we will find g prime x, right? So this is g of x, right? We want to find g prime x. So remember the rule, we want to put it in power form. So that's not in power form. What's square root of x times root x? It is x. Root x times root x is x. Right, root x times minus 1 is negative root x. 3 times root x is plus 3 root x. And 3 times minus 1 is minus 3. This is still not in power form. So this is x plus 2 root x minus 3. Still not in power form. So x plus 2. Remember the rule for surds. X to the power mn is inside over outside, so it becomes x to the power m over n. Remember the rule. So inside is 1, outside is 2, so x to the power half minus 3. So that is g of x so far. Therefore g prime x is now equal to derivative of x is 1. Remember the derivative of constant is 0. I did it in the previous step as well. The half times 2 is 1. And x to the power minus half. Right, let's leave it like that. And then let's write in positive exponents. Right, so 1 plus 1 over x to the power half, which is the same thing as saying 1 plus 1 over the square root of x. That's the final answer. Next question, question number 9. Right, so some good questions there on derivatives. Let's see what we have here. Lovely. We have derivative function, not derivative function, sorry, we have a cubic function. So the graph of f of x is equal to 2x cubed plus 3x squared minus 12x is sketched below. Guys, you can't get anything simpler than this, right? Because the equation of this function is already given. You can find the turning points, you can find the x-intercepts, you can find basically everything. A and B are the turning points of f. C is 2, 4 is a point on f, right? C is a point on f. Simple, simple. Let's look at the question. Determine the coordinates of A and B. To find the coordinates of A and B, those are just turning points. So 9.1, we need to find the derivative. So you're going to say, let me write y equals, the function is y equals. So let's write it in terms of y equals 2x cubed plus 3x squared minus 12x, right? So you can say y prime is now equal to 6x squared, 3 times 2 is 6x squared, right? 3 times 2 is 6, subtract 1 from the power, 6x squared plus 6x minus 12, set it equal to 0. Divide everything by 6, standard form, so we got x squared plus x minus 2, which is equal to 0. Factorize x and x, which is equal to 0. We can use 2 and 1 plus 2 minus 1. So x is equal to 1 or x is equal to minus 2. Now we got the values values of the turning point, which is 1, and that other value of the turning point, which is at minus 2. Now since the value lies on the graph, we need to substitute into the original function. So we need to substitute 1 in the original function. If I substitute 1 in the original function here, I'm getting y is equal to 2 plus 3 minus 12, right? So 2 plus 3 minus 12, you can see minus 12 plus 2 is minus 10 plus 3 is minus 7. I've got minus 7 here. Remember, because I'm substituting 1, so x is kind of like, it's just 2 times 1 cubed, 3 times 1 squared, minus 12 times 1. So 2 plus 3 is 5. 5 minus 12 is minus 7. Or y is equal to, let me substitute minus 2 inside here. Now I'm going to use a calculator for that. Right. So 2 into minus 2 to the power 3 plus 3 into minus 2 squared minus 12 into minus 2, right? And we're getting an answer of 20. Y value is 20. So the coordinates of A is minus 2 and 20, and the coordinates of B is 1 and minus 7, and it's making sense. The y value is negative here and the y value is 20 on top. So what's the coordinates of A? Sorry, this is the coordinates of B. So B's coordinate is 1 and minus 7, and A's coordinate is minus 2 and 20. Sorted. For which values of x will f be concave up? Now when you're doing concave up, it means f double prime x is just greater than 0, and it's a very easy solution for this, right? When you're doing concave up. Or you can find the x values by finding the midpoint of minus 2 and 1. The midpoint of minus 2 and 1, minus 2 plus 1 is minus 1, and divided by 2 is minus half. So it's going to be at minus half. When it is concave up, when x is greater than minus half. Let's see. So therefore x is just greater than minus half. Let's see if this answer is actually true. We're going to find the double derivative rather, right? So 9.2, we're going to say, what was my y function? My f of x was equal to 2x cubed plus 2x cubed plus 3x squared minus 12x plus 3x squared minus 12x, and we found f prime x, it was equal to 6x squared plus 6x minus 12. And then if I find f double prime x, I'm getting 12x plus 6, right? Now it needs to be greater than 0 for concave up. For concave down, it needs to be less than 0. and for inflection point it's going to be equal to 0. So let me write those rules down. F prime x greater than 0 implies concave up, right? In other words, happy face, that's what you're looking for. F double prime x less than 0, looking for concave down, so basically looking for a sad face. And F double prime x equal to 0, we're looking for inflection point where the concavity changes, right? That's what an inflection point is. Concavity changes. In other words, from up to down or down to up. So solving this equation, we got 12x is greater than minus 6. Divide both sides by 12. Therefore, x is greater than minus 6 over 12, which is minus half. And I showed you over here where you can actually find the midpoint of the turning points values. Simple way. See the midpoint of the turning point values. 1 plus minus 2 is minus 1. Minus 2 plus 1 is minus 1. Divided by 2 is minus half. So there it is concave up from here and upwards. Remember, to find the inflection point y value, you do not add up these y values divided by 2. You rather take minus half and substitute into this original equation. And so it's concave up all the way. Let's take that out. Alright, now continue here. Determine the equation of the tangent to f at 2, 4. Equation of the tangent. Now, when you're finding the equation of the tangent line, obviously we need a gradient function, right? So 9.3, what's the gradient function? F prime x. Tangent line, equation of the tangent line, let's just draw a line here, right? Finding the equation of the tangent line at that point there, right? So obviously you need the gradient of the line. And what's the gradient of this line? The gradient of this line occurs at 2. So we basically need to find the gradient, which is f prime x. We actually need to find the gradient, which is f prime 2, right? So remember, let me just draw the stuff over here. So looking at point C over here, which is 2 and 4. Point C was 2 and 4. Yeah, 2 and 4. Finding the equation of this tangent line, right? So yt, I call it yt, equation of the tangent line. So what's the gradient of the tangent? Gradient of the tangent is f prime 2. We already got f prime x. What was f prime x? F prime x was 6x squared plus 6x minus 12. So when I say 6x squared minus 6x plus 12, 6x squared plus 6x minus 12 plus 6x minus 12, right? So we should get an upward sloping gradient. So we're going to substitute at x is equal to 2, substitute 2 inside here. So 2 squared is 4, 6 times 4 plus 6 times 2 minus 12. So I'm getting a gradient of 24. So let's just double check this answer. If I'm substituting 2 inside here, where's the other derivative that we found? Substituting 2 inside here, so 24, that's plus 12 minus 12, so 24 is correct. The gradient is 24, right? And then we can just say y is equal to mx plus c at 2 and 4. Remember, m is 24, x is 2 plus c, and y is 4. So what do we have? We have c is equal to 4 minus 24 times 2, which is 48. So value of c is minus 44. Therefore, equation of the tangent is equal to 24x minus 44. And that should be your solution. And that ends off the calculus. Let's see, you can see this line is very steep and is going right down and intersecting at minus 24, right? And then what was question 10? So we have solved all these questions here. Question 8, 9, Question 9 is done. Yes, let us have a look at question 10, which is maximization. Question 10. Yeah. So the graph of f of x is equal to ax cubed plus bx squared plus cx plus d. So that's a cubic graph, cubic function. Right, the following information about f is also given. F of 2 is equal to 0. F of 2 equal to 0 basically means y value 0. So this is basically the x-intercept. The x-axis is the tangent to the graph of f at x is equal to -1. So there's a turning point. Tangent means, right, tangent to the x-axis is the tangent to the graph of f at x is equal to -1. So there's a turning point at -1. Let me see what points we are looking at. Let's draw the axes here. Right, so we're dealing with -1. So x-axis is a tangent to the graph of f at x is equal to -1. So we got a turning point on the x-axis. So -1 and 0. So it's either here. It can be either here or it can be down here. Right, so we don't know which graph it is. F prime 1 is equal to 0. So we got 1 here and we've got 2 there, and we're also dealing with a half. See, remember the 2 from there, that's the x-intercept. We got a half inside here. F prime 1 equal to 0 means there's a horizontal tangent at 1. So now the horizontal tangent can be a turning point there, right? At 1 there's a turning point there, not at 1 over here because you already got twice here. Or you can have a turning point here, right? Horizontal tangent here. So f of 2 equal to 0, that's the x-intercept definitely. Now this is a very important information where they're saying f prime half is greater than 0. In other words, the gradient at half must be positive. So obviously you can't have a graph going down like this. You can't have a graph going down like that because the gradient will be negative. So you need to have a graph which is going like that, and then obviously through there and down. Perfect. So that's our graph. Okay, so let us resketch this. So if I have to resketch this graph here, right, so 2 is my x-intercept. At 1 there's a turning point, and at half, which is in between here, right, we've got the gradient needs to be positive. In other words, it's increasing and it's going through there, and that's my graph, that -1. You can see there's a horizontal tangent at -1, right? Horizontal tangent at x is equal to -1, right? At 2 there's at x is equal to 2 is a x-intercept. At half, f prime half is definitely greater than 0 because this function is increasing, and there's a turning point at 1. That's what we need. Everything is fine, right? So let's just label it again, x-axis, y-axis, and that's my graph of f. Right, let's look at 10.2. 10.2 should be maximization. Yep. Right, so O is the center of the circle. O is the center of the semicircle passing through A, B, and C and D. O is the center of the semicircle passing through A, B, C, D. Perfect. The radius of the semicircle is x minus x squared. So the radius is x minus x squared. So we can put it on this triangle here. The distance from there to there is x minus x squared. Even this radius, remember OA is equal to OB, which is x minus x squared. Units for 0 to 1. The value of x must be between 0 and 1. AOB is a right angle at O. Right, so that's a right angle triangle. So obviously if these two are equal, that should be 45 degrees and that should be 45 degrees, angles opposite equal sides. Show that the area of the shaded part is given by area of the shaded part is given by, yeah, what's the area of the shaded part? We can take the area of the, yeah, so you can take the area of the quarter circle, because this part here is 90 degrees, because this part over here is 90 degrees, this will definitely become a quarter circle. It's part of a quarter circle, because if you think about a full circle here, right, and if I just put the lines like anyhow, if I put the lines, one line going this way and one line going that way, see, so I can still get a 90 degrees there. Just say if that's 90 degrees, remember that's 90 degrees. Remember this angle plus that angle, you're getting two 90s here. So you kind of, this is like kind of a quarter circle, this piece over here, this sector. So this entire sector over here. So we can take area of quarter circle minus the area of the triangle. Yeah, so we should do that. We should get the answer. Let's try that out. Area of quarter circle minus the area of the triangle. So 10.2.1, the total area of the shaded portion here is area of quarter circle, right, minus area of triangle AOB. Right, so what's area of the quarter circle? Area of the quarter circle is this entire region here minus the area of the triangle, right? So area of quarter circle is pi r squared divided by 4, subtract. We can just do half base times height from here, and so half base is r and the height is also r. Half base times height, remember this is r and this is also r, so pi r squared divided by 4. We already have r. I think we can take out something as a common factor. We can take out r squared as a common factor, and we got pi by 4 minus half. R squared is basically x minus x squared, that is your r, and this here should just be 4 pi minus 2. Seems like we're getting the answer. We got pi minus 2 over 4, and if we square this we should get the answer. So therefore area is now equal to pi minus 2 over 4 into, if you square this, if you square the minus x squared, you'll get x to the power 4. If you square the x, you should get plus x squared. The middle term is minus x cubed times 2, minus 2x cubed. Yeah, so we do have the answer. You can write some reasons. You can say AO equals BO radii. Remember AO equals BO radii, right? And yeah, we didn't need the angles there either way, right? So that's our solution. 10.2.2, determine the value of x for which the shaded area will be a maximum. So value of x for which the shaded area will be a maximum. Value of x for which the shaded area will be a maximum. So a prime is equal to a prime x. Remember this function is in terms of x. So a prime x is equal to, just thinking what you're going to be doing with this. You're going to take this inside. So when you say 4 times that factor will always remain there, right? If this factor always remains there, example, I can just call this f into x to the power 4 minus 2. So if I call it f, just a factor, if I call this f, which is a factor, then if I take this inside, that factor will always remain there. So you're going to end up factorizing the factor as well. So you can just leave it out, x minus 2 over 4, and just differentiate the inside over here. You don't have to take this inside and then differentiate the whole thing. So just differentiate this. So you got 4x cubed. Differentiate this, 4x cubed minus 6x squared plus 2x, because you're differentiating this 2 times, yeah, is equal to 0. And then you can just make this part disappear because we are setting it equal to 0. We're finding the maximum value. So we can take out a common factor from here, which is an x. So we can say this is 4x squared minus 3x plus 2. Sorry, you can take out a common factor of 2x rather. But take out a common factor of 2x from here, left with 2x squared minus 3x plus 1 is equal to 0. Let's see if we can factorize this. So we got x is equal to 0. X equal to 0 not going to give you any area. You can see you're getting 0 here, 0 times that, so that's clearly not applicable here. Or solve this. Can we solve this equation? We got 2x. Let's try to factorize. 2x x is equal to 0, 1, and yeah, looks like it works out. You can use 1 and 1 here, minus 2x minus 3x, yeah. So x is equal to half, or x is equal to 1. The question is which one is going to give us a maximum, right? So remember, they give us a boundary for values of x that you can choose. X only needs to be between 0 and 1, right? So since the value of x is between 0 and 1, this is not applicable as well. So that should be your solution. X is equal to half should give you the maximum. Did they ask for the maximum area? Determine the value of x for which the shaded area will be a maximum. So that should be your solution. X is equal to half. Now question 11, guys, I have solved in question 11, which is on probability, grade 11 probability, and 11.3 is on counting principle. This was quite a difficult question, right? 11.3.2. so just see my explanation and let me know if you understand. And by the way, question 11, I'm not doing it in this video because I've already uploaded that, and please see for link in the description. And here's question 11. It was on probability and counting principles, so I have done this already, right? So I hope you enjoyed this video, guys, and I hope I make a difference to your understanding. If you need any more help, please let me know, and don't forget to subscribe to my channel and share it with your friends. Thank you very much, guys.